Okay. Okay. Hello. Welcome back. Sorry. This is 1530 College Algebra, and if you remember back when we originally worked with systems of equations, we had these weird systems like 2x minus 3y equals 5, and then 4x minus 6y equals 7. And you try to solve them, right? And you go like, all right, I can multiply this first guy by -2 maybe. You got negative 4x plus 6y equals -10. And then 4x minus 6y is 7. And then the variables -3. Okay, so then that would be no solutions, right? This stuff happens when you have bigger systems, and we want to see them in the context of matrices, and how to identify them there. The inconsistent is basically the no solution cases. So that word inconsistent, think of it as things are out of order. It's not working. So that'll be the no solutions case. Inconsistent. And then the dependent is the infinite solution case. Okay. So let's go ahead and take a look at no solution cases. No solution. And we're calling these inconsistent. Okay. And they'll be mixed in general with your regular matrix problems. So here we go, 2, -4, 1. So you'll begin just like we did before. You want a 1 in the pivot position, 0 below it. Okay. Try to copy it down correctly. Okay. So first things first, we want to get a 1 in this first pivot position. So I could do a swap. Okay. So row swap that. Row 1 with row 2. So I'm going to get 1, -3, 1, 5, and then 2, -4, 1, 3, and then the 3, -7, 2, 12, as usual. Then I need zeros below the pivot position. Okay. So what am I doing? -2, row 1 plus row 2, and then -3, row 1 plus row 3. So row 1 is not changing. Let me do my arithmetic here in blue. -2 times row 1, -2, 6, -2, -10, and then row 2 is 2, -4, 1, 3, -3, row 1, -3, 9, -3, -15, row 3 is 3, -7, 2, and 12. Doing the arithmetic now, 0, 2, -1, -7, and then 0, 2, -1, -3. Okay, what's next? I want to get 1 in the second pivot position. So I need to get a 1 here. So it looks like I'm going to have to multiply by 1/2. And we'll have some fractions. 1/2 row 2. 3, 1, 5. 0, 1, -1/2, -7/2, 0, 2, -1. So it's business as usual, you're just going along, trying to do your Gaussian form. Okay, right, so business as usual. So I need to get a 0 below my pivot position. So I'm going to go -2, row 2 plus row 3. 1, -3, 1, 5. 0, 1, -1/2, -7/2. Okay, the arithmetic. -2 times row 2. So I get 0, -2, 1, and 7. And I'm adding that to 0, 2, -1, -3. So I end up with, after adding 0, 0, 0, and then 4. Okay, that's the big red flag. This thing, if you were to reinterpret it as an equation, well, what would that say to us? So I'd say 0x plus 0y plus 0z equals 4. In other words, they're trying to tell you that 0 is equal to 4, which we know is not true. So that's a false statement. So there's no solutions. That's the no solution occurrence in the context of matrices. Okay. So when you're working with variables and equations, you would get something like 5 equals 3 or 0 equals -3, like we got in our example here. In the matrix, this is what it looks like. Okay, so no solutions or inconsistent. Okay, let's look at the infinite solution case then. And this is pretty simple too. The problem though is writing up your answer. I think that's the hard part, but we'll get you there. Okay, so let's look at number 4. And we have 5, -11, 6, and then 12. -1 and 3, -2, -4, and then 3, -5, 2, and 4. And business as usual, right? So I'm going to swap the two, row 1 and row 2, because I need to get a 1 in the first pivot position, and I'm trying to avoid fractions. Okay, so here we go. So I have -1, 3, -2, -4, and then 5, -11, 6, 12, and then 3, -5, 2, 4. Then I'm going to multiply that first row by -1. So it'd be 1, -3, 2, 4, 5, -11, 6, 12, 3, -5, 2, 4. Okay, then I need to get zeros below the pivot position, so right here and here. Okay, so 2 birds with 1 stone. -5, row 1 plus row 2, and then -3, row 1 plus row 3. And what do we get? So 1, -3, 2, 4, and then I got to do some arithmetic. -5, 15, -10, -20, plus 5, -11, 6, and 12. The other guy, -3, 9, -6, -12, and then 3, -5, 2, and 4. Okay, so we add those guys. I'm getting 0, 4, -4, -8. And then the last row, 0, 4, -4, -8. And you kind of see something fishy happening at this point, right? Those 2 second rows are exactly the same. So anyways, if I was just proceeding blindly, like a computer, my next task would be to get a 1 in the next pivot position. So I'm just going to go 1/4 times row 2. And I would have 1, -3, 2, 4, 0, 1, -1, -2, of course 0, 4, -4, -8, and then you're trying to get zeros underneath the pivot position. Okay, so of course you go -4, row 2, you just use the row above it, plus row 3, and row 1 does not change. Row 2 does not change, but row 4 does. So doing the arithmetic, I have 0, 4, -4, +4, +8, and then 0, 4, -4, -8. And what you get is a row of all zeros. Whoops. So we got 0, 0, 0, 0, and that is what happens when you have infinite solutions. If you were to rewrite it as an equation, you would get 0x plus 0y plus 0z equals 0, 0 equals 0, which is a true statement. So we have infinite solutions. and it's called the dependent case. Okay. So the hard part is kind of writing up your end answer. So let's convert it back to equations first. So x minus 3y plus 2z equals 4, and then y minus z equals negative 2, and then usually you would have z equals something, right? Well, here z can be anything. They call it free variable. Z is just whatever it wants to be. It can run around in the field and be happy. It could be anything. So usually what the book will do, or what the software will do, is just call it t or something like that. I don't know why. You could call it z, I think. And then backsub. Okay, so you're going to plug it in there and solve for the other variables. So you have y minus t is negative 2. In other words, y equals t minus 2. And then you're going to take that and plop it back into the first equation. Okay, so you'll have then x minus 3 times t minus 2 plus 2 times t equals 4. And you want to solve for x in terms of the free variable. It should be z, but for some reason they use t. So x minus 3t plus 6 plus 2t equals 4. You get x minus t plus 6 equals 4. And then you're going to get x equals t minus 2. Okay. So at the end of the day, your solution, to write it up, what we're going to do is put it in terms of this free variable. So we have t minus 2, and then the y part is t minus 2 again, and then the z part is just t. Or if you'd rather, z minus 2, and z. Okay, that's it. Okay. Now, because of this abstraction that we're dealing with, we can look at non-square versions. In other words, we can now, instead of just always having to work with like 3 equations, 3 unknowns, 5 equations, 5 unknowns, 7 equations, 7 unknowns, you could actually work with 7 equations, 2 unknowns. You could work with 10 equations, 3 unknowns, et cetera, et cetera, et cetera. Okay. So let's take a look at one of those. So here we have 2 equations and 3 unknowns. And the process is pretty much the same. You just kind of pretend that you're trying to get a square matrix out of it somehow. 2, negative 5, 10, 19, 1, 2, negative 4, 12. So business as usual, you want to get a 1 in this first pivot, the kind of pivot, quote-unquote pivot positions. So you're hoping to get a 1 there, and then a 1 on the other in the other diagonal. So you're hoping to get a 1 here as well eventually. Okay, but if you can't get a 1 there, the weird thing is you kind of push it over here, and then you kind of say, okay, if I can't get a 1 there, I'll try to get a 1 in the next position over. If I can't get a 1 where I want it, so it's a little weird. Getting used to, definitely. So anyways, I could do a switch swap on the first 2 rows. So row 1 and row 2. Just switch them, and you get that 1 in that position. So 1, 2, negative 4, 12, negative 2, negative 5, 10, 19. And then, like I was saying, you know, it's kind of business as usual. So we need 0 below the pivot position. Okay, so I can go just 2, row 1 plus row 2. Row 1 is unchanged. Oops, that should be a positive 2, not negative 2. So I sort of butchered that number. Okay. So negative 4, 12, and then we need to do some arithmetic. Okay, so 2, 4, negative 8, 24, plus negative 2, negative 5, 10, 19. So we're getting 0 there, and then negative 1 here. I'll put it in white, sorry. 0 here. 0 here, negative 1 here, and then 2, and then 3, carry the 1, 43. Okay. So it looks like I'm going to get a pivot in there. If this ended up being a 0, if this position ended up being 0, what you do is just kind of go over to the next guy and try to get a pivot position there. So try to get a 1 there. Okay. So you try to get 1 here. If not, you try to get a 1 in this position. Okay. But I think in this case we're able to do it clearly because we just multiply by -1, right? So -1 times row 2, and we get 1, 2, -4, 12, 0, 1, -2, -43. Okay. That kind of does it for us. We can now convert back into our system of equations, and then we'll have a free variable again. So this will be y minus 2z equals -43. So again, just let z be anything. Let it be itself. Usually just call it t for some parameter. And then what are we doing? Sort of back subbing and stuff. So first take this and plop it back into here, and then solve for y. So we have y minus 2t equals -43. So y equals 2t minus 43. Then you take that expression and plop it back into there, solve for x. So we have x plus 2 times 2t minus 43 minus 4z, which is t, is 12. And of course we'll get x plus 4t minus 86 minus 4t equals 12. T's cancel. X minus 86 is 12, so x must be 98. Okay, so our final solution is 98, comma 2t minus 43, comma t. Okay. Okay. That'll about do it. And okay, thank you for watching, and have a good day.